Good afternoon. I'm John Yembrick with NASA's Office of Communications. Welcome to the NASA Social to preview Orion's first flight test, which is scheduled to launch at 7:05 a.m. Eastern from Cape Canaveral Air Force Station in Florida. Thank you very much. We have, for those watching at home, we have about 150 people in the room here at Kennedy Space Center. The majority of them are NASA social media followers. We also have connected to us and tuning in social media followers from 8 field centers across the country. The hashtag for today's event is simply Orion. That's also the hashtag for the test flight. If you hear us talk about something that doesn't quite sound like Orion, if you still continue to use that hashtag, that would be appreciated. And we're going to be talking about things other than just Orion today at this briefing. We're also going to talk about, for example, our commercial crew program. Soon, we're going to be flying U.S. astronauts on American spacecraft to the International Space Station and back. And also, we're going to be talking about our journey to Mars and how the Orion test flight is a stepping stone to that endeavor. So to get us kicked off, let us start with our first speaker. He is a veteran of 4 space flight missions, and also the director here at Kennedy Space Center. Please help me welcome to the stage Bob Cabana.
Thanks, John. Hey, are you guys ready to see history made tomorrow? So you realize, if you've done the math, you know, our last flight to the moon was in 1972. It's been 52 years since we've had a human spacecraft, even though there isn't a crew member in it, go as far from planet Earth as Orion's going tomorrow. That's pretty darn neat. This is our stepping stone to the future. This is our first step into deep space exploration, into going to Mars, and I think it's absolutely outstanding. The administrator is going to be here shortly, and before he does, I just want to tell you a little bit about some of the transformation going on here at the Kennedy Space Center, preparing for that future. I don't know if you've had a chance to look out the window here on the patio, but if you look out to Launch Pad 39B, the northernmost pad, it's totally different from how it was during shuttle. All the shuttle infrastructure is off there. Those 3 big lightning protection system towers that are put in place, you know, that's the launch pad we're going to go to Mars from. You know, we're flying Orion on a Delta IV Heavy right now, but the Delta IV Heavy, the furthest it's going to get Orion away from Earth is 3,600 nautical miles, all right? It's going to re-enter at about 85% lunar reentry velocity, but that's the best we can do with the Delta IV. We're building a space launch system, and it's going to launch from that pad, and it's going to eventually take us to Mars from that launch pad right out that window. All the shuttle infrastructure is gone. It's got a new propellant distribution system, totally refurbished. It's got a refurbished water suppression system. It's got fiber optics. It's got new computers. It's going to have a new flame trench. That is our launch pad for the next 30 years. Over in the vehicle assembly building, right out the window here, High Bay 3, all the shuttle platforms are gone. And when we say platform, you know, you think about something the size of the floor of this room. That's not a platform. The platforms in there are the size of small buildings. All that shuttle infrastructure is out of there. New platforms are going in to accommodate the Space Launch System. Now, this rocket starts out at 70 to 90 metric tons, right? But it grows to 130. Well, those platforms are designed to accommodate the evolving outer mold line of the vehicle as it gets wider and taller up at the top. So those platforms are designed to adjust 8 to 10 feet up and down, and they've got inserts in them so that as the outer mold line gets wider, you can pull out the one insert, stick in another one, and you don't have to redo everything. It's going to be awesome. The crawler transporter, totally redone. Crawler Transporter 2. We got 2 of them. Crawler Transporter 2. Got new wheel bearings in it to accommodate the heavier weights of the mobile launcher and the Space Launch System. It's got new jacking, elevation, and leveling cylinders. It's got new brakes. It's got new generators. It is totally being refurbished to be our Crawler Transporter for another 30 years. It's going to take that mobile launcher that you see out next to the vehicle assembly building that's being modified for the Space Launch System. It's going to weigh about 6 million pounds. The rocket's going to weigh another 6 million pounds. The Crawler Transporter weighs 6 million pounds. That 18 million pounds is going to roll 3 miles out to Pad B. We're going to fuel that rocket, and in fiscal year 2018, we're going to be launching on Orion on another test flight, again without a crew, on its way to the moon. And at this time, I want to welcome our administrator, Charlie Bolden, to the stage. Charlie, come on up.
How you doing? Thanks very much for everybody who's on the net. I understand there are people on from every NASA center around the country, I hope, anyway. Real quick, because I know you all have questions you want to ask. Hopefully, Bob's given you a lot of the technical stuff and all the details, so I'm not going to repeat anything. But again, I want to thank all of you for coming. It's a really exciting time for all of us, and I can only imagine how exciting it is for you. Did you already ask them how many people have done this before?
No.
How many of you have seen a launch of any kind before? Wow, this is pretty. Let me put it this way. Who's not seen a launch of any kind before?
All right.
Hey, now that's good, okay? It's going to be pretty neat. So, sort of, that's an understatement. Anyway. But
you said this morning what it was going to be.
It is. It's going to be a BFD. But other than that, it's... Bob and I had the privilege earlier this morning of actually going out with the folk from ULA and Lockheed Martin and kind of standing right beneath the vehicle, and it is very, very, very impressive. So, again, thank you all for coming. Thanks for what you do. Why don't we try to go to questions? And since I've got Bob captured here, he's going to have to go do work. But two?
We'll try to push it, Charlie.
Okay, okay.
Hands, please. Here we go.
And are questions coming in from the hinterland?
Okay.
No?
According to Al Warden, from what I've heard from him, when the parachute failed on Apollo 15, it was due to low winds that day, allowing RCS fumes from the RCS fuel dump to travel up the lines up to the parachute. Has that been accounted for in the new Orion capsule design, and how much redundancy is there for safety in case of chute failure?
You have just surpassed the technical knowledge that both Charlie and I have.
Hey,
This is why we have really smart people working for us who unfortunately are not here with us right now to answer that
you
question.
picked the two guys who really don't like using parachutes as two pilots, and so we're just going to be very
We
candid.
did use a parachute. It was just a
It
slow
was
down
just
one
a
on the
slow
runway.
down one on the
Yeah.
runway. So we apologize. We'll get you an answer, though, okay?
Okay.
Don't forget.
but the
you know the answer to that? You don't? You're smart.
Rex. Oh, man.
We have...
Rex knows the
I will
answer. He'll
tell
tell
you-
you when he comes up.
The parachutes were designed at the Johnson Space Center. It's a great design. They've been thoroughly tested, and I'm confident that they're going to work exactly as they were designed.
We learned a lot of stuff about parachutes, though, like trying to get to Mars and that kind of stuff.
First off, thanks for coming over here today and spending some time with us. I've seen in a few of the social media boards a bunch of naysayers saying that this is not such a big deal and all this other stuff. How do you guys go ahead and respond to somebody like that?
I said it's a BFD, and so that's my no. But in all seriousness, it is a big deal, and it's a huge deal for the nation. When you stop and think that this will be the first time we've launched a vehicle intended to carry humans beyond low Earth orbit in more than 40 years, people ask, what's taken so long? So that is a legitimate question. Yeah. To question whether it's a big deal or not, I don't think is fair or legitimate at all. It is a huge deal because this is a continuation of what the Apollo astronauts started. You know, when I talked to Neil Armstrong, when I did talk to Neil Armstrong and others, they went to the moon not just to go to the moon. They viewed their lunar missions as a precursor for humans going on to other places, Mars being one of them. So we have taken a 40-year hiatus in trying to make this trek, and now we're back on the path. I think for the first time, at least since Bob and I have been engaged in the space program, we're closer than 30 years away from going to Mars.
And the team is really excited about it. When Charlie mentions that they were looking forward to Mars, even when they went on the moon, that first Apollo 11 crew, you know, that went to the moon, the first crew to actually be on the surface, brought us a patch. We have a patch signed, and it's signed by the Apollo 11 crew to be taken. You know, it's for the crew to take to Mars when they go to Mars, and that was back in 1969. They thought of that. You know, the other part of this is, if you look at the Apollo missions, the longest Apollo mission was like 12 days. The Orion capsule, it's bigger. It's designed for a crew of 4. It has, with a crew of 4, it has a 21-day design life in space. It is a big deal. It's a much bigger design, and we know a lot more now than we knew back during the Apollo program to really make this our deep space vehicle. Now, obviously, it has to hook up with a habitability module to be, you know, for extended periods of time, but with a Crew 2, we got at least 27 days with it.
Who's here from somewhere other than the U.S.? I know there are a lot. You know, you weren't a partner when we went to the moon. We didn't have any partners when we went to the moon. There was no commercial space when we went to the moon. So what is big about this is that we have now reached out and we're engaging more people in actually being a part of this than I think many people ever dreamed of. When in the days of the Apollo era, you know, the Cold War, we were involved in a space race. We're not in a space race anymore, no matter what anybody tells you. There is sort of a little space race, but that space race, thank goodness, is among American companies trying to see who can be the best, who can be the most efficient, who can get the cost down the most, and they're forcing you know, manufacturers around the world to take a look at their processes, at their pricing and everything. So that is a tremendous difference. We're not only doing technological advances in terms of hardware, but we're doing game-changing advances in terms of business practices, how you do things, okay?
And when I look at international partnerships, I look at the International Space Station. When you consider, you know, we got Russia, Canada,
Tomorrow
Japan,
is
the
his
European
anniversary,
Space
so
Agency,
make
and
him
all
tell
its
you about it.
partners. You know, we have learned how to work together in space, the agreements that had to go into place to make that happen. And I think it's a model for how we explore in space, how we work in space together, and it set the stage for how we're going to explore when we go beyond planet Earth. And as Charlie mentioned, I do have to throw this out. I think it's kind of cool. Tomorrow is the 16th anniversary of the first space station assembly mission, and we're launching the very first mission on our new vehicle to explore beyond, starting a new
Commanded
era.
by his truly
Yeah, but that doesn't matter.
endeavor.
Charlie, Bob, this is a unique event. We actually have 8 space flight centers or NASA field centers on the line. We have a question from NASA Ames.
Great.
Go ahead, NASA Ames. Go ahead.
Great. Hey, we're happy to be here and representing NASA Ames. We wanted to ask you what the significance of the name Orion is, and it seems to pop up in a lot of programs, but it is attached to this program. We want to find out a little bit more about why it was named Orion. Thank you.
I don't have a clue, but I'm going to tell you what I read, okay? And I'm going to tell you, I really don't. And I just read this the other day, and I'm counting on, because it came from a media person, so I'm counting on it being true and well-researched. That is not said tongue-in-cheek. Orion came about in the constellation program, and the team at the time felt that what more appropriate to be a part of a constellation program than to name it for a constellation, Constellation Orion. So that's what I am told, that's how the name came about. You know, subsequently, or most of the times, we go out nowadays and we ask kids to help us name things. I think NASA named it internally, but I don't know, for real.
Sounds good to me.
Bob says it's close and he was still around. But that's the answer I got when I consulted one of my most valuable assets, which is U.S. media.
We'll come back to the room in a second. We have one more question from Field Center. We have a question from Glenn Research Center. Glenn?
Hi. Can you tell us what factors go into the launch window? Because you're not trying to rendezvous with anything. So could you just explain that to us, please?
I think we got about a 2.5-hour launch window on this one, and it's, you know, I don't know what the end cutoff is, the requirement. I'm sure it's requirements on the vehicle and fueling and a few other things. It depends on where they are in the count. If it were a shuttle, I could tell you precisely, but yeah, I don't know what the limiting factor is on why it's where it is. But the weather forecast for tomorrow is 70% go. The weather off the California coast is great for recovery. With a 2.5-hour launch window, I'm fairly confident we're going to find time to get off.
Rex, where are you? Is Rex coming on next? You're later? Okay, go find out 2 things. Why did we pick Orion as a name? And so you can answer his question about why 2.5 hours instead of all day. Ah, spoken as a true expert. Did you? Hey, come get a mic real quick. Here you go. Come on up, Rex. I know we're cheating bringing Rex up early.
Oh boy, thanks.
Come on in here. Come on up. Come on up.
Sure.
Explain that.
So I would
Here's your
say
answer there.
it's kind of a complicated calculus they have to go into, because they have to maintain the ability to launch the vehicle from here, but they also have to have the ability to retrieve it. And we're trying this out for the first time. This is not easy to pull a vehicle into a well-deck ship the way we're recovering it. So they have to have enough crew duty day, enough lighting out in the Pacific to recover it in time. So I think that kind of narrows down the window.
See, I would have guessed that. But it would have been a guess. And Rex is a current active astronaut, and he's been involved in all this stuff, so he's going to give you all the straight scoop. Okay.
We have time for one more question, and then I know the administrator has to run. So I This is just easy. It's right here in front.
I'm curious to know, are there any scientific experiments or missions that we're leveraging as part of this test launch? So even though it's a test launch, are there even some short experiments that we're sending up
The
for
one
this
that
flight?
I'm most proud of is coming out of something called the Exploration Design Challenge. And the scientists are high school students from the Hampton Roads, Virginia area who won the Exploration Design Challenge, co-sponsored by Lockheed Martin and NASA, where we went out and said, look, radiation is one of the biggest challenges for us, radiation and its potential damage to the crew. Can somebody help us come up with a way to protect the crew during long-duration flights to Mars? And there were like 25,000 responses within a day. I think in the end we had 100,000 or so contestants, and an expert panel of people picked the 5 finalists. So all 5 teams should be here at the Cape for the launch in the morning, and the winning team from the Hampton Roads area near Langley Research Center actually have their experiment inside Orion being flown. So that's one science experiment that I know is being done. The other experiments relate to thermodynamics. We're looking at the heat shield and whether or not it is strong enough to withstand the temperatures and pressures of reentry in about an 85% scenario for coming back from the moon. We're looking at its communications and other stuff, looking at the navigation and control on board during the flight. And then going back to the parachutes, that really is aerodynamics. And so we're looking at essentially high-speed aerodynamics, the performance of the parachutes as they try to open in a case where we're coming back, starting out at 20,000 miles per hour and then decelerating.
It's a great test flight. I mean, we're looking at separation of the launch abort system, the panels on the service module. It's got 1,200 sensors on it that are specific for getting data. There's like 50 miles of wiring just for the sensors that are unique to this flight for gathering data.
Any of you sailors? Okay, you know how when you're trying to go back and forth and you're trying to get to something in the ocean and you're doing this mental gymnastics, you're doing the trigonometry and the geometry in your brain? We've got the crew of the USS Anchorage that is a helicopter. Well, it's an amphibious readiness vehicle that carries Marines around the world, and they're getting ready to deploy. But before they deploy, they're actually going to recover the vehicle tomorrow afternoon. And having been aboard, watching them go through one of the final exercises, it was actually incredible to watch this crew, the navigator working with the officer of the deck underway to determine exactly where they go and how they approach the capsule that's floating out there. They had to take winds into consideration, the drift of the ocean waves and all this other kind of stuff, so that when they got there, the vehicle wouldn't go zipping by them and they wouldn't have to do U-turns and everything else. So it is an art as much as a science just to pick the vehicle up. And I didn't even mention that as a test, but this will be a very important test for the U.S. Navy to make sure that they understand how do we successfully pick up this vehicle, because a couple of flights from now, it's actually going to have people in it. And we want to make sure that we pick them up as quickly as we can, first pass, so we can get them out of that thing, because they will have been, in space around the moon and doing all kinds of stuff, and we really want to get them out as quickly and safely as we can. So this is that's probably the final test for the vehicle, is to see if we can integrate the Navy in and make the successful pickup. So that's it. You all have been great. Thanks so much for letting Bob and me come in and intrude on your time.
Thank you.
Thank you.
Thanks so much.
Thanks, John. I appreciate it.
John, thank you.
Thanks, Charlie. So we are going to Mars. NASA is going to Mars. What are we doing right now to learn about how we're going to get there? What are we doing on Mars right now, and how is this helping tell that story? Not only that, what kind of technology do we need to do to actually make that happen? Let's roll the video.
As we expand our presence into the solar system with human and robotic exploration, we're learning more about the formation and evolution of Mars, which can help us learn more about our own planet's history and future. In the past, the red planet had conditions suitable for life, And future exploration may uncover evidence of life, answering one of the oldest questions. Does life exist beyond Earth?
NASA's on a journey to Mars, and the first humans who'll set foot on Mars are alive on Earth today. Rovers and spacecraft are on and around Mars, studying its conditions, revealing its history, and showing us the red planet like never before. On Earth and in space, we're doing the hard work to prepare for missions farther than ever before. First to an asteroid and then onward to pioneer Mars.
During the past 40 years, NASA explored Mars through robotic spacecraft, landers, and rovers, dramatically increasing our knowledge about the red planet and paving the way for future human explorers. Future missions seeking signs of past life will demonstrate new technology that could help astronauts survive on Mars.
I think some of the most amazing things that we're learning are actually how to be really good detectives on another planet, which is a really difficult job.
NASA's human mission to Mars begins in low Earth orbit aboard the International Space Station, where astronauts are proving technologies and communications systems needed for human missions into deep space. The space station also teaches us how the human body changes in space, so we can protect astronaut health on long-duration missions deeper into the solar system. NASA will test other new technologies needed to send humans to Mars in the first ever mission to capture and redirect an asteroid mass to a stable orbit around the moon. Astronauts aboard NASA's Orion spacecraft will explore the asteroid in the 2020s and return to Earth with samples. This experience will help NASA test new systems and capabilities such as solar electric propulsion, which is a highly efficient way to send heavy cargo ahead of human missions to Mars. Astronauts will travel in an Orion, launched atop a Space Launch System heavy lift rocket, which will be the most powerful rocket ever flown.
Apollo happened before I was born, so this for our generation will be the exploration missions that we get to see in our lifetime.
The journey to Mars will improve lives on Earth in important ways. We'll increase scientific knowledge that could help us better understand Earth. We'll also develop new technologies and economic opportunities right here in the United States. And we'll advance U.S. leadership in the peaceful international exploration of space. But make no mistake, the journey to Mars will be the challenge of a generation. To send humans to the red planet and return them safely so we can go back, keep exploring, and push the frontiers of discovery. It's a journey well worth the risks.
Today, our engineers and scientists are working hard to develop the technologies astronauts will use to travel to and work on the red planet. Join us as we continue our journey to Mars.
And joining us live here today to talk about NASA's journey to Mars, from left to right, is the Associate Administrator for Human Exploration Operations, Bill Gerstenmaier. To his left is the Associate Administrator for Science Mission Directorate and a veteran of 5 space flights, John Grunsfeld. Following him is the Associate Administrator for Space Technology, Mike Gazarek. Our Chief Scientist, Ellen Stoffen. And our Chief Technologist, David Miller. Let's start with Mr. Gerstenmaier.
Thanks, John. It's great to be here. It's really exciting to look out in this audience and see a lot of young faces and folks that are actually excited about what we're talking about and what we're doing. And it's not that I meet other audiences that aren't there, but I don't typically meet audiences with this demographic. So this is pretty awesome for me to get a chance to see you and get a chance to interact with you. We'll talk to you a little bit about the journey to Mars, and we'll answer a lot of questions. I think the thing that's important, and John will talk about it in a minute, is, we're really on Mars today, and John will describe that. So we're already there. We're doing the International Space Station, where we've got crews on orbit today that are actually preparing and understanding how the human body performs in the microgravity environment of space. We're understanding how our hardware systems operate on board space station for the long durations will be required to go to Mars. So we're really gaining really critical data today that helps us kind of pave that way going forward on space station. Next year we'll have the one-year expedition on board space station. It'll be great to just get a data point to see what it's really like to go beyond the 6-month period and see if there's anything from a human physiological standpoint that changes that requires some extra help. You've got the exploration flight test, which you're all down here to see today, to see the Orion capsule fly. It's pretty exciting seeing all the work that's come together to put that vehicle together and to see the teams that are really ready to go execute that mission. And we're kind of beginning to move forward. So I think you can start to see real progress as we're moving on this journey to Mars. You know, I often put the focus really ought to be on journey. This is something that is not easy. It's not going to be easy for us to go do. The scientific information that we're getting from John is absolutely critical. We have a radiation monitor on Mars today, which is helpful for the human aspects. We're going to do a 2020 rover with John and Mike Gazarek, and we're going to have an ability to pull oxygen out of the Martian atmosphere to go look at the ability that we could use some of the resources at Mars so we don't have to carry everything with us. So to go from where we are today in the Earth-reliant region to the proving ground to Earth-independent is going to be just a huge journey, a huge challenge, and that's really what we're all about. So it's not just Mars, it's not just a single mission, it's actually pushing human presence into the solar system. So, John?
Thanks. Welcome, everyone. This is really exciting. Of course, I grew up always wanting to launch rockets and had the privilege to fly on some, and tomorrow we get to watch a really cool rocket launch. At NASA, I believe our mission is to innovate, to explore. When we explore, we discover, and when we discover things, it inspires. How many of you were born after 1976? Yeah, quite a few hands going up. No, you were not. Well, for all of those of you that were born after 1976, you've never known a time when we have not been exploring on the surface of Mars. And right now we have amazing fleet of spacecraft at Mars, both in orbit and on the surface. And I think I have one chart that shows this, if we can bring that up, much of which you already know. But what we found out about Mars is really amazing, you know, and especially the Curiosity rover. How many of you have heard of Curiosity? Right, so Curiosity, she has a Twitter account and a Facebook page, and she tweets. But in fact, it really is human exploration. It's all about engineers driving Curiosity, scientists getting the scientific information, and vicariously exploring Mars through the eyes, through the cameras, through the selfies of Curiosity. And it's really exciting. Our goal was to find out, was Mars ever habitable? Could it have had an environment that would sustain life? And that was the big goal. Really challenging, hard to get to the ground, 7 minutes of terror. Curiosity lands, looks around, and says, holy beep, I landed in a dry riverbed. I mean, literally, the geologists, the planetary scientists looked around and said, this looks like a dry riverbed in West Texas. Rounded pebbles, concretions, riverbank, encoded in the rock. The rock tells the story about an ancient Mars that probably had a thick atmosphere, puffy clouds, rain, snow-capped peaks. And so now we're driving along exploring what looks like terrain that supports that hypothesis that Mars was really a happening place. Mars was once habitable. And as Bill said, there are resources on Mars today. What happened to that water? Well, we just have the MAVEN spacecraft enter Mars orbit and start science, and it's orbiting high in the atmosphere and seeing Mars lose hydrogen today, hydrogen from water that's been dissociated by ultraviolet light from the sun. The oxygen stays, hydrogen's really light, whoosh, off into space. And so we're seeing that process happening today. But something in Mars's ancient history between 3.5 to 4 billion years ago and today caused it to lose that thick atmosphere. And so we're trying to read the rock record and figure out what happened. But even today, the Mars atmosphere is mostly CO2. Anybody know what the next most abundant atmospheric component is? Argon. We have a lot of argon on Earth, too. It's really interesting. Then nitrogen. There's CO2, argon. We see nitrogen in the atmosphere. We see oxygen in the atmosphere. We see carbon monoxide in the atmosphere. As far as I know, we haven't seen methane yet, which would be really interesting. But we also know that in the rocks themselves is a lot of water trapped in the minerals, few percent. And we may be able to drive that water out. Same is true on the moon. Really interesting. So that's a resource we might use. If you have water, you have hydrogen and oxygen, you can make rocket fuel. You can breathe the oxygen. I suppose if you really wanted to, you could drink the water too, and you probably would. And there's a lot of ice still on Mars. We've seen brand new craters from our Mars Reconnaissance Orbiter where some meteorite has hit the surface of Mars, created a new crater, and when all the dust gets blown out of the crater, we see ice that then over subsequent orbits sublimates into the atmosphere. So if we land on Mars with humans sometime in the near future, and I hope we do, we'll be able to use those water resources and just melt the ice and create rocket fuel, drink the water, create oxygen. So it's a really exciting time, but message is we're exploring Mars today. The Opportunity rover has driven over 40 kilometers. The Curiosity rover is driving around trying to answer these really incredible questions about past habitability and maybe even detect if there are organics, fossilized organics in the soil from past life. Who knows? We're working on a lander in 2016 that's going to be a geology field station. 2016 and 18 partnering with the European Space Agency. How about that Rosetta mission and the Philae lander? Pretty cool. You know, ESA's really got their game up, and we're partnering with them on those missions. And then in 2020, we have a collaborative effort to send a rover that's going to drive around, really great instrumentation. It's going to grab samples. It's going to convert CO2 to oxygen and store it in a tank. And it's a partnership between, really a one NASA partnership. And one of the partners is Michael Gazarek. Over to you.
Oh, thanks, John. That's fun. Thank you. Well, I'm really excited to be here. There's nothing like a rocket launch, right? And I don't know about you, but I think about all the hard work that went into the vehicle for tomorrow, all the engineering, all the design for years. You know, it all comes down to those crucial moments of launch. It just really, I don't know about you, but it kind of brings out the excitement in me in this whole what's going to happen, you know, tomorrow morning. Deep space exploration. That's what this is about, right? And really, as Bill mentioned, the journey begins tomorrow. For the first time, right, putting this vehicle further away from Earth than we've ever had in decades and bringing it back safely. That's really excitement. It really leads the way. So that's really the journey for deep space exploration, the journey to Mars. So who would like to go to Mars? Anyone interested? Yeah, me too. Yeah, I know, me too. Me too. Here's the thing, though. We got a couple things we got to do to get there, right? We know there's some challenges to get to Mars. There's some capabilities that we need to get to Mars. And this is where technology, as you can imagine, really plays a role. So we talk about getting to Mars. There's challenges to get there. We got challenges. We got to land there. And then we got challenges where we got to live there. And, you know, and eventually then get back. So that's what technology is about. And we're working on those things today. Just last month off the coast of Hawaii, maybe some of you saw it. If you don't, we just launched what the LA Times called NASA's Flying Saucer. We didn't label it that. We had a more, you know, acronym name, LDSD, but we kind of went with the Flying Saucer, right? It's kind of cool. But we took that up at high altitude, conditions like Mars, to go figure out better ways to slow down. Why do we want to slow down? We got to get more mass to the surface of Mars that we can today. We got to land on more of the planet's surface than we can today. Today we land in craters. We need every ounce of that atmosphere to slow down. We want to do better than that. We got more things to go put on Mars that we're going to need to go live there. So we got to figure out how to do that. And we learned a lot about how to slow down on Mars. In fact, we shredded a parachute, if you've seen the video. It's pretty awesome. Yeah, so we're learning. Just to be clear, we're learning. That's what we're doing today. We know now today more about the supersonic inflation dynamics of a parachute than we did 3 years ago. 3 years ago, we stood up the Mission Directorate of Technology, and we're developing new capabilities today. We also have developed a composite cryotank. What's so important about that? Well, it can store the fuel, the rocket fuel that we need, and it reduces the mass. It allows more payload to get more things to the surface of Mars. We demonstrated that this summer. When we talk about going to Mars, we need a propulsion system. And one of the ways we're looking at is something called solar electric, using the sun's energy and then turning that into these Hall thrusters that send out ions out the back that give us this continuous thrust to get to Mars. Well, we need bigger solar arrays. Didn't have them 3 years ago. We do today. We did that this summer as well. So all across the board, we are flying and demonstrating where we have to, above the skies of Hawaii on a flying saucer that we had to build. We're using the International Space Station across the board to develop better thermal exchangers, to develop better navigation systems, to better life support systems. We have worked today in how to recycle the oxygen on board. We know we can't take it all with us. We have to recycle the water, of course, and getting to closed-loop systems so we can recycle the water, recycle the air. We're working on all those today. We're working on better batteries. The same battery life issues we all have on all the cool iPhones. Speaking of technology, right? Same problems you have, right? We all got to go home and charge them tonight. And if you forget, you're not going to, you're not going to set your alarm. You're going to miss the launch. So make sure everybody, please charge your phone tonight if you're like using that alarm. But we got to work on better battery density. Well, we have work on that as well today. So that's just a couple examples. We're working on all those: how to get there, how to land there, how to live there. All working today with the International Space Station and whatever we need to do, whatever we need to go fly on, to develop the capabilities. So the journey starts tomorrow, and I can't wait. Ellen?
You know, NASA is the keeper of the future, and a big part of that future is Mars. And as John talked about, why? And it's because of this issue that we really do think that the conditions on Mars, we just don't think. We know the conditions on Mars existed for long periods of time where life could have evolved. So we can really get at that fundamental question that has been around in humanity for so long: are we alone? You know, we're addressing it in other cool ways too. The James Webb Space Telescope, after 2018, will start looking at the atmospheres of extrasolar planets. You know, we want to go study Europa, Jupiter's moon, that has these subcrustal oceans that we think are super interesting. So there's lots of amazing things we want to go do. But right now, we're really focused on Mars. And to me, this is incredibly important because I'm a geologist. I go out in the field and bang on rocks with my rock hammer. And I think that piece of sending humans to Mars is critical to understanding the science in the long run. Finding life on Mars may not be easy. Studying life on Mars is going to be challenging. And having humans on the surface who can be creative, who can be iterative, who can be innovative in how they're approaching it, who can cover large distances in short amounts of time, who can adapt to new information as they get it. Robotic exploration is great. Don't get me wrong. We've done amazing things with Opportunity, with Curiosity. But we need humans to go to that next step of really understanding Mars in a true scientific sense. So what we're doing tomorrow, to me, is incredibly exciting because we talk about this, and a lot of us see the progress behind the scenes that some of you might not be aware of. The research we're doing every day on the International Space Station is so critical to this journey to Mars. Understanding the effects of microgravity on the human body, you have all these conditions that occur: muscle wasting, bone density loss, changes in intracranial pressure. These are effects that we're studying, we're finding ways to mitigate so that we can send astronauts safely on that 8-month journey to Mars, 8 months back, and have them healthy. That's what NASA does. So that research that we're doing every day on the ISS is really critical to this journey to Mars. Mike was just talking about the technology work we're doing every day that's critical to this journey of Mars. The work we do every day with Curiosity and Opportunity and Maven that are helping us on this journey to Mars. So we're on our way, but tomorrow is such a visible sense of, we're on the cusp of sending humans beyond low Earth orbit, which we haven't been able to do in such a long time, that we're really excited about tomorrow. And I hope everybody sees this as we're on our way to Mars. Thank you.
Well, it's great to be here today. It's very exciting in advance of the launch tomorrow. When I think about the journey to Mars, I really think about it as a technological journey. It's one of many different journeys we're making. And tomorrow is a very big step in that technological journey. But as Mike has mentioned, we've already been working on in other avenues as well, on space station, in our labs, developing all the other types of technology we need. So this is not the first step in our technological journey to Mars. It's an important step, but we've been working on this journey. I'd say we're well on our way. One of the things I want you to remember and think about, and I try to remind myself every time, that a lot of times we think about technology as performance enhancing. It is, but I think we also need to think about it in terms of affordability and sustainment. This is a very long journey, and we also want to, in the process, pioneer that path. And that means it's a long journey. So technology is going to help us to be able to afford it and sustain it. And over time, as technology emerges, we need to think about technology refresh, because on a long journey, that's essential to being able to sustain that journey. Another aspect is technology drives exploration. It's kind of in the background sometimes, but we need to think about not only that technology is essential for sustaining exploration, sustained investment in technology is also essential, and we need to keep that in mind. You know, I like to sort of draw an analogy with a water faucet and a sink. You know, we can't think about it as something we can turn on today and then turn off, and in a few years hence we can turn it back on and innovation is just going to sprout like water from a faucet. It doesn't work that way. We really need to keep that sustained investment so we can keep this journey going. So let me ask you about, anyone seen a launch before on TV or your computer? Okay, I figure we're with this crowd. How about seeing it live? Okay. Anyone been actually on a launch? Okay. Well, it narrows down quickly, doesn't it? So what I would say, I guess I'm speaking to the people on through the camera here. For those of you who've only seen it on TV, you're really missing a lot. It really does change your life. I encourage you to, if you go to Orlando on a family vacation or to DC, you know, check on the websites for the Wallet Flight Center or Kennedy Space Center to see if there's going to be a launch while you're there, and go see it live. It really saturates all of your senses. You know, it's brighter than anything that TV can show you. It's louder than anything that you can hear from TV. It actually literally shakes you. It's a very emotional event. I guess if it saturates your senses of taste and smell, you might want to back up a little bit. It might be a little close. So, but you know, the build up and everything, it's really extraordinary. You really have to see it live, and I encourage everyone to do that. I just wanted to close by saying that I strongly feel that exploration demands a sense of urgency that keeps us on our toes. As soon as we get on our heels, I think we're in trouble. So it really demands that kind of urgency. So you know, when you have a launch system like SLS and Orion, an exploration system, the best thing you can do is fly it a lot and fly it far. But we really need to be able to afford it. We really need to be able to sustain that. We need to be able to sustain a cadence of missions so that we keep everyone engaged, not only our engineers and our scientists working on the projects, but also grab the attention of the public and keep them engaged on that journey as well. So that's essential. I've seen in the various avenues that I've worked that there's a passion out there for exploration. We need to really fan the flames on that passion. We need to engage it. There's a broader community that's working on all aspects of this problem. I think we need to tell their story along with our story, because if we can tell their story of excitement and achievement, then I think they'll help us tell our story as well and make that journey reality. So, thank you.
Thank you, David. Appreciate it. And from the rest of the panelists, we have time for some questions here in the audience, and then we're going to go to our field center. If you have a question, please keep your hand raised high, and we'll try to get to you.
Hi there. First of all, thank you all. That was very, very informative. Thanks for taking the time to talk to us. So we talk about Orion, and it's part of NASA's journey to Mars. I have to wonder, how would Orion actually get explorers to Mars, onto the surface of Mars? We see a capsule. We see something that's made for space flight. How will it actually land on the surface and then return? Is there something in the works that we haven't seen yet?
Yeah, the intent of Orion really is not to go to the surface of Mars. It's part of the potential transportation system that will be used as combined with a habitation module that will allow us to make the journey. But then there will be a descent kind of vehicle, and then there'll be some kind of ascent vehicle to come off the surface of Mars. You know, we're still kind of trading some things in terms of how we would actually put this together. We've been working on the asteroid redirect mission, and with the Science Technology Mission Director, we've been looking at solar electric propulsion. And that turns out that that's a very effective way to move large masses around the solar system. So what we're thinking we may do is we may actually pre-position cargo and maybe even the ascent vehicle and the habitation systems on the surface of Mars before the crew actually goes. So we may actually, we call it a split cargo mission. So we would actually fly the cargo first with electric propulsion. It takes maybe 2-3 years to get there with electric propulsion. Then we pre-position all these assets at Mars. They're there also for repeat journeys to come back again later, but they're there, they can be checked out. And then we bring the crew on chemical propulsion in a fairly short trip, could go down to the surface with some kind of lander vehicle and then some kind of ascent vehicle that potentially used the resources on Mars to prepare us to come back. And then we come back to the vicinity of the Earth, and then we return from the Earth, or from the vicinity of the Earth down to the surface of the Earth. And that's conceptually what we're starting to look at. John?
I'll just add one thing is all journeys start with one step. All space journeys start with getting off the Earth, and Orion is that piece. It's that vehicle that gets us off the Earth and into deep space where we can start our journey.
And the other key piece is the Space Launch System, the Heavy Lift Launch Vehicle, that allows us to take large masses to space. And those masses are needed for the Mars-class mission. Because if you look at the resources, space station roughly weighs 900,000 pounds. We kind of estimate for a surface landing on Mars, we roughly need to have about that same mass, roughly, to go do that kind of activity. So this is really a big endeavor to go to Mars.
Which is why we're shredding parachutes to go figure out how to get out. We could, Bill, could you, go a little less maybe, right? So it just, yeah, that's the challenge for entry descent.
Because again, John's landed roughly a metric ton with the rovers on the surface of Mars. We're thinking we need to 20 times that, maybe 20 metric tons, 30 metric tons to land on the surface of Mars. So that's where Mike comes in with how do we do entry, descent, and landing into this atmosphere that's thick enough to provide heating, but not thick enough to provide significant braking.
Yeah, I think just for the record, I think the scorecard is Mars. I think it's 19, and Earth, I think it's now 20 actually. With Maven, I think it's 20 successful missions to Mars. So we just got over 500. So go Earth.
I was just going to add that I think Mike's team really sort of parses it out well. I think you say we have to go, we have to land, we have to work, and we have to leave and return home. And I think the round trip is essential because you need those voyagers, those sort of ambassadors to the New World to come back and tell them how exciting it is, and they can really give that human element to it. And when you think about those 4 steps, you can start seeing where the landing larger mass, maybe we can refuel rockets by getting some of that water out of the regolith and so forth. And it's a good way to sort of think about it.
Good afternoon, and thank you so much for having all of us here with the NASA Social. As you were just saying, it's going to be incredibly difficult to land on Mars and support habitation on Mars, and it's going to take decades. Some stepping stones. A stepping stone that certainly you're considering right now is visiting the asteroid and retrieving it. I'm curious about what other stepping stones you might be considering. For example, short of landing on the surface of the Mars, would a mission to visit Phobos, for example, make sense? Or what are the other waypoints that we may see before we get to that step of landing on the surface?
Again, we're kind of actively trading all those things to figure out what the right approach is. If it seems if you're going all the way to Mars, maybe just passing by and then coming back without landing, or going to Phobos or Deimos or doing something there. I don't know, we need to trade those advantages and disadvantages. So I think if you take a look at it where it's not a single mission where we're trying to, essentially do it one time fast, but we're actually trying to put infrastructure in place, how do we effectively use these other pieces of the solar system effectively? So do we use the moons as a staging point? Are there advantages there? And we're starting to trade with the whole technical community what the right answer is to go do that. And there may not be one answer. There may be several different approaches that we're looking at as we think about this activity. And others may want to comment too.
I like to think about it for those of us that were born before, what was it, 1975? I like to think, back in the 60s, they had some good ideas. There was the Mercury, the Gemini, the Apollo mission. And now we have this concept where there's Earth reliant, the proving ground, and then Mars ready. And I think there's a nice parallel that can be made, because what we're doing on station is Earth reliant, it's low Earth orbit. It's we have to resupply and so forth, and you can get back within hours. But that's where we're learning to sort of live. It's kind of like what we did in Mercury. And then the proving ground is where we're going to go out to cislunar space, out beyond the moon, further than we've been before. And that's where we're going to learn how to actually work and be productive and exercise these technological tools that Mike's developing. And then when we're really ready to go, then it's the Apollo, and that's where, we're Mars ready and we can go and be independent and we know everything's going to work right.
Great, thank you. Now let's take a question from one of our field centers. I believe we have a question from Goddard Space Flight Center. Goddard?
This is Ben at NASA Goddard. So in the book, The Case for Mars, the case is made for in situ for manufacturing the propellant to return from a Mars mission on Mars using possibly helium or hydrogen brought in from Earth or other means. I'm wondering if that is being considered for the upcoming plans to take humans to Mars.
So in the case for Mars, there was a plan to bring hydrogen from the Earth to Mars and use Sabatier catalyzation to create methane, for instance. What we've learned about Mars is there are plentiful local resources. You don't need to take hydrogen to Mars because there's a lot of hydrogen on Mars today. There's water. In fact, Mars has a relative humidity. We have an instrument on the Curiosity rover that measures the relative humidity. In principle, we could pull water out of the atmosphere and use that hydrogen and oxygen. And if you have hydrogen and oxygen, you have rocket fuel. That's what we power the space shuttle with. That's what we launch rockets with. Very good fuel. Or we could make hydrocarbons because we have hydrogen, oxygen, and carbon dioxide. So we have carbon and oxygen there. And there's a huge gear ratio for using, a huge advantage for using local resources because you don't have to take it with you. And so on the Mars 2020 rover, which we will launch in 2020, we have the in situ resource utilization experiment that's a partnership between all of us to use CO2 to produce oxygen. So that's a first step. So that'll be a catalysis of stripping off the carbon and saving the oxygen. So that's a first step. I think whatever our next steps are for surface missions, we're going to try and increase the capability and scope and try different things so that hopefully sometime within the next decade or so, we try something at a scale that can create rocket fuel on Mars.
First, everybody, thanks for coming over and talking to us today. John, just real fast, a quote you like to say is, all exploration is human exploration. I've stolen that quote several times, so thanks for driving that point home. Just a real question with the collaboration between the technology side and the science side. How closely are you guys working together? Is there like a good comm channel between you two? Say the science side finds something interesting on, Curiosity finds, hey, we just found something that we should tell the technology folks. And has there been a finding that sort of impacted what the technology side has been doing? Thanks.
Yeah, it's a great question. So the answer, short answer would be yes. From a technology standpoint, we want to develop technology with a purpose, right? We want to solve problems. So what do we want to solve? Well, the customers, the way I look at it, are John and Bill. What do you need? And so we've worked really hard. In the 3 years that the space technology has been up and running, we've worked really hard to improve that connection with science and what do you need. And we have now a number of activities that we're doing in support of science. And in fact, one example, for those following the Discovery 14, this is a competitive announcement in the science community to go do great science. That announcement of opportunities open to the community, that explicitly lists 7 technologies encouraging the science community to use. There's some incentivization in there. And those were technologies done in combination with John. Hey, what do you need? What does the science community need?
So let me give you a very specific example about things we've learned. And it's not necessarily just discoveries, although that factors into it, the water within rocks that maybe we can then extract by heating them and driving off the water. But more importantly, sort of a corollary of all exploration is human exploration. The Curiosity rover takes a lot of great images with all of its cameras. Most of the images stay on Mars because we don't have the bandwidth to get the images back to Earth. And even in the drive-in, the analysis of the scene and trying to get high-resolution images so that we can plan what the next traverses 100 meters will be like. So we can tell the rover to drive autonomously, for instance. To get all of those images back takes a long time because we're railing up through an orbiter and then through the deep space network back to Earth. If we had optical communications, so instead of radio, we went to optical, we could have high bandwidth, get that data back to Earth, increase the science exploration, but also allow us to operate better. And when we get to human scales, we're really going to want that. And so we're looking aggressively at optical communication, which is technology investments by technology, and then it'll be operational inside of human spaceflight, and we'll all take advantage of it.
Unfortunately, we only have time for 2 more questions. I know we have them here in the room.
Hi, again, like everyone else, thank you so much for coming and talking to us. I apologize, this is a really nerdy question. I've spent a lot of time reading the 5th Design Reference Architecture. It's a really great document about a possible path to Mars, but it's getting old at this point. I mean, it still basically is referring to the Constellation program. Is there any plans to kind of be doing a DRA-6 at some point, or is that just not where your resources are right now?
Talk to you about the split mission concept of where cargo goes first. That's this next version. We call it the Evolvable Mars Campaign. So instead of being a specific design reference mission per se with finite points, we're going to try to make it a little bit more flexible with some kind of off-ramps and other pieces. The other piece that's important is look at where we can reuse components. So maybe the habitation module that goes to Mars, maybe we actually park it someplace in a high elliptical Earth orbit. We may park it around the moon in a distant retrograde orbit where we might put the asteroid. There's certain things we're looking at to trade to see if those make sense from an overall standpoint. So you're going to see us come out probably next year with kind of an update of a plan of how this is starting to come together. But it's not going to be as discrete maybe as the Design Reference Mission 5. It's going to have a little more softness in it, a little more flexibility in it so it can show the paths. And then we want the community to help us figure out exactly the right way to go do this. Because I think things will change over time. To think we know all the technology that will be in place and exactly how things will work today, and we try to project that 20 years in the future, that's not a very effective approach. You need to be ready, and if some new technology comes online or a new way of doing business is there or something's there, we're ready to adapt and move that. And we haven't built such an infrastructure that's so rigid it can't adapt and change to those pieces. So you'll see something probably next year.
Yeah, that's a nice difference and a very important one, I think, that we have to emphasize is we all operate and live in a certain world, and you need to plan accordingly, and we can't be rigid in our plans. That flexibility, I think, is what makes this new plan really different and essential.
And I think the other real strength of it is what you see up here today. It is science, technology, and human exploration working really closely together to say what's the best plan to really optimize all the different areas of NASA to make sure we're coming up with a flexible path to make getting to Mars a reality.
Hi, thank you very much. I'm Julia, and I run a fashion tech blog called Technically Sweet. And I think there's a lot of people that are underrepresented that would like to hear about some of the fashion technology or the wearable technology that the astronauts are pioneering with this amazing NASA resources. Are they wearing or using anything, any advancements that we might be able to trickle down to all of us for accessibility purposes or for everyone to utilize later on?
Well, one thing we have on board Space Station today is we typically do a lot of EKG measurements on our crews, and typically you have to place the electrodes on your body and stick them in and hear them. We now have a vest, and you can just simply put the vest on. It automatically puts the electrodes in the proper position for the crew members, and then the data can be telemetred down to the ground for the folks to look at. So that's one thing we're doing, and we're starting to use those type of things. We also use the active watches. I think John probably wore one when he was in space that keeps track of sleep cycles and information along those lines. They all wear dosimeters so they can look at the radiation environment during their missions, those kind of things. So there's lots of little pieces of medical technology that we're starting to put on our crew members to capture data unintrusively. We also have some new shoes we have with the accelerometers in the bottom of the shoes, so when they run on the treadmill or they do the advanced resistive exercise device, you can actually look at the loading that's going into your femurs and to your lower bone structure to see if there's a correlation between bone loss and how much loading you get through your exercise. So these are devices that make it transparent to the user that they don't have to consciously even think about it. The data just gets collected.
Of course. When you get dressed to go spacewalking, we have the helmet-mounted cameras that we've had for a number of years, and I see quite a few head-mounted cameras here. That's a critical component. And the cool thing for us is it allows the folks that are staying inside of the space station to see, so we can communicate better. But more importantly, folks on Earth actually can experience a spacewalk that way too.
And I'll just say from a more way cool fashion, if you ask me. Of course, I'm a guy. I don't know what I know about it, but my wife tells me I don't know much. But Dava Newman at MIT did some advanced work under the advanced concepts, and she's been nominated as NASA Deputy Administrator. And if you look at some of her, advanced suits, way cool.
One last plug is there's a document called Spin-Offs, and I encourage you to download the electronic version because the bound version is so thick and heavy. But that's because there's so many things that are spinning off out into the out in industry for other applications.
The question was, what are the spacesuits made out of that are going to Mars?
And that's a really, anybody here a material scientist? I think actually we probably haven't invented the material yet, but people are working on it that will form the basis of those spacesuits. That's one of the areas that's really ripe for discovery, is our ability to customize and build brand new materials, which of course is the essence of the fashion industry.
And then there's the anti-fashion industry. This is, we carry a lot of clothes for the crews to wear, so we're looking at long duration clothing material. So we have stuff with silver fibers in them. We have various other materials that don't absorb sweat and don't let bacteria grow. So we're looking at how long you can go without changing your clothes. So this is kind of the anti-fashion world. So you would have one outfit for your entire Mars duration of 360 days. Now, no one may ever talk to you, and the Martians will run away from you when you get there. But we're starting to experiment with some of that because it is a big volume if you have to carry a lot of clothes and a lot of material with you.
And for terrestrial explorers, mountaineers, and long-distance sailors, they typically only bring one pair of clothes for months, so it's no big deal.
And Gilligan's Island was on for years, and they just wore the same outfit. So, unfortunately, that's all the time we have with our panel. Give a round of applause to... Thank you. So while our exploration goals are going deeper and further into space than ever before, we're also investing in commercial companies to keep us fly astronauts in low Earth orbit. Let's roll the next video. Commercial Crew Program, Phil McAllister. Phil?
Hey, thanks a lot. Hello, everybody. So I only have 5 minutes. I've got so much to tell you guys in 5 minutes. That's really hard for me to say commercial crew in 5 minutes. Plus, I can't use acronyms. Now, it's doubly hard for someone from NASA, but we do hard things at NASA, so I will give it a try. So what is this thing we're calling commercial crew? I think the best way to describe it, you've seen the shuttle, everybody's kind of familiar with that, and now you hear commercial crew and you think, well, is NASA getting out of the business of transporting astronauts up and down to low Earth orbit? And the answer is no. We're just doing it in a slightly different way. If you remember the shuttle, we all have a soft spot in our hearts for the shuttle, particularly us here at NASA. If you think about how that was produced and how it was made, NASA was really in charge of just about every aspect of that development, right? We owned and operated the hardware. We made every decision about how it was going to operate. We did have the private sector produce it for us, but under very exacting specifications. We had over 12,000 requirements that we gave to the private sector for them to build the space shuttle. And at the end of the day, we were the only customers. That's how we did it before. And how would we like to do it in the future? If you think about, when we think about the vision for transporting people to low Earth orbit out in the future, it's very much like aviation. So I live in DC. When I came down here to Orlando, I bought a ticket on United. I went to the airport, got on the plane with a lot of other customers, and got down here to Orlando for a reasonably good price. I'd always like it to be lower, but it was something that a normal person like myself could afford. That's how we would like it to be in the future, going up and down to low Earth orbit, where NASA employees just buy a ticket from a company that's providing this service to multiple customers to go up and down to low Earth orbit. Now that's in the future. So what are we doing today? That's really Commercial Crew. And what we're doing today is a public-private partnership where we are sharing the risks, we're sharing the financing, we're sharing the design decisions about how we're going to develop these next systems to get our people up and down to low Earth orbit. So the private sector is bringing their ingenuity, their innovation, and their attention to cost effectiveness, which is really important. And NASA is bringing some financing ourselves, as well as our experience and lessons learned from all of our previous human spaceflight generations to do something that we think is going to be super powerful, have safe, reliable, and cost-effective space transportation to and from the International Space Station and to low Earth orbit. And we think that's going to be an effective way to move forward, but we're only, again, talking about low Earth orbit. You've seen all these great things that we're doing. Tomorrow's test launch, we're going to Mars and the planets, and that's really more of a traditional NASA role. We don't see many customers for going to Mars besides NASA in the near term. So I think having this combination of the private sector taking more responsibility for low Earth orbit operations, which is something that we've been doing for 40, 50 years now. It's still hard, but it's gotten to be a little bit more routine. So it's a little bit more easy to see a transition for the private sector to take more of a role in doing that. But when you're going out to, say, the moon and Mars, that's a really, really difficult thing that we see more as a traditional NASA mission. If you want to think about it, the International Space Station, it's about 250 miles away from the Earth. The moon is about 250,000 miles away, so that's a lot harder. And Mars is about 150 million miles away, so that's even much harder, obviously. So this combination of having the private sector take more of a role to low Earth orbit and NASA still pushing the state of the art, we think that's what America's human spaceflight program should look like in the 21st century, where private sector is bringing their skills and ingenuity, and we are bringing our experience and also our history and knowledge, and together we build these really, really strong systems. And I think that's going to make space travel more accessible to everybody. That is certainly the hope in the future, that we drive down the cost. We've seen this in just about every mode of transportation. Initially, it's very, very expensive, but as entrepreneurs come in and innovations and competition, and you really drive the cost down. We've seen it. A good analogy is climbing Mount Everest. If you think those first expeditions up to Mount Everest, they were government financed. They were very expensive, took a very long time. Today, many, many more people can do that. You don't see governments doing it. It's personally financed. You have commercial operators doing that and helping people go up and down. We hope to see that kind of transition as well. And the reason why I think this is so important to bring the private sector more involved in, if NASA was the only organization that did space exploration, we would always be limited in our space aspirations by the NASA budget. We get between $15 and $20 billion a year, and if we were the only ones doing it, that's as much as we could do in space. When you bring the private sector and they can help with this financing, you think about it, there's really no limit to what we can do in space except our imaginations. And that's what's really cool to me. That's why I get really excited about Commercial Crew. We're trying to expand our economic sphere out into low Earth orbit and the solar system. And why that is so important is we've seen over time how tenuous our human spaceflight programs can be. Once we get economic interests out into low Earth orbit, there will be no turning back. We will have planted, as I like to say, our first sustainable flagpole in our exploration of space. Once we have economic interests and the private sector more involved in space exploration and particularly low Earth orbit. So where are we? I'm going to stop talking really fast, right? Am I up over my 5 minutes? I'm sure I am. Yes, I am, of course. Sorry. Yeah, okay. Lastly, just where are we in this development? We started in about 2010, so we're about halfway there. We'd like to see the first missions to low Earth orbit around the 2017 timeframe. So again, it takes a long time. I know in today's day and age, if we have a 6-month-old smartphone, it's a dinosaur. These things are hard. They take a long time, but hopefully we'll see the first Commercial Crew missions to the International Space Station by about the 2017 timeframe. Thanks.
We have, to start with, take questions in the room, and then it'll go to some of our field centers. Please raise your hand up high.
Hi. What sort of research is being done on the International Space Station to prepare for long, deep space exploration as far as muscle loss for the astronauts?
That's a great question. I'm probably not the best one to answer that. Probably somebody from the International Space Station can talk to you about that. We've got plenty of research, but that is one of the keys to the International Space Station, is trying to figure out how we can live and operate long duration in space. So that is one of the key functions. And when commercial crew becomes operational, the key is we're going to be able to add an additional astronaut on space station that's dedicated specifically to research and helping us figure out those things. And so that's one of the reasons why we think commercial crew is really important. If you think about it, we've had continuous human people in space for 16 years. There's 6 people on orbit right now. You can see them fly overhead about every 90 minutes on the space station if the conditions are right. So we've learned a lot, but we have a lot more to learn in order to go to Mars in terms of the things you've heard about, muscle deterioration, bone loss, and things like that. And that's why getting up and down to the International Space Station is so important, and we want to do it often, we want to do it safely, and we want to do it cost effectively.
Hi, thank you for coming. And real quick, for commercial space with SpaceX and other providers, who is going to provide the actual control of the vehicle and training of the vehicle? Is that all going to be done at Houston, or is that going to be done at SpaceX headquarters?
Right, so that's really up to the companies. They're going to be responsible for training the crew, and they're going to be responsible for operating the spacecraft. So it's really up to them. We will probably see some sort of partnership. Again, we've got a lot of training facilities within NASA, and if the companies want to utilize them, we're going to make them available on a reimbursable basis. But I would suspect most of that activity to happen at the company's facilities, and I think that's appropriate. We want them to be able to do not only NASA people, but again, other customers. And so they have to be able to do this without NASA, and we really hope that they're able to accomplish that, because again, that's in our interest, because then prices go down, and we like that.
Phil, we're now going to take a question from the Jet Propulsion Laboratory in Pasadena, California. Pasadena, California.
Hi, I've been following all the innovations that Sierra Nevada and SpaceX have been doing with designing their spacecraft. I was wondering if any of those companies comes up with anything really innovative, like a system to return the rocket back to the launch area, or being able to land with propulsion rockets on land. Will NASA be adopting any of those activities or any of those innovations if they turn out to be something really groundbreaking?
That's another advantage to commercial crew. We've had multiple companies competing for these for our agreements and contracts for commercial crew, and they all have a different way of going about doing it. We're all going up and down to low Earth orbit, but as an engineer, it's really cool to see how the different ways that they come up and do these things, and really bringing their own ideas and innovations to the task of getting people up and down. So I think that's very likely to happen as these companies get better at it. Then that can actually spin in to NASA, and we've seen some of that already. It's actually helped with the way we're doing commercial crew, with more of a trying to reduce our requirement set and things like that, and using that for a more traditional mission. So that's another way commercial crew is advantaging the agency. If you remember, I said we had about 12,000 requirements for shuttle. For commercial crew, it's about 300. So the companies have significant flexibility to innovate and come up with these interesting propulsion mechanisms. Abort systems is another innovative area that we found our commercial crew partners coming up with, and several others. And I would expect to see some of that spin back into NASA.
Okay, we're now going to take a question from the Johnson Space Center in Houston. Go ahead, Johnson.
Hi, sir. Thank you for your time today. Just wondering if you could speak to maybe some of the other commercial opportunities you might envision for private sector in besides space taxi operations going up into orbit.
I've seen a lot of ideas from companies, either asteroid mining, putting up their own private space stations, satellite servicing. The moon has a lot of opportunities. You've got the Google Lunar X Prize and things like that. I almost see, not limitless, but there's so many potential ideas. Again, we're only limited by our imagination. And of course, a good business plan. That's what's important. These companies are in this to make money and to make a profit, and that's where this all has to come together. So there's really just a whole laundry list of things that I think that people have proposed and companies are working on. I would use up all my time if I started listing those, but I gave you just a few.
We are going to go take one more question from Field Center. We'll come back here to the room. We have a question from Langley Research Center in Virginia.
Hi, kind of continuing on what could be done to... Technical problems. Sorry, but what do you think can be done perhaps either with Orion or to encourage the private sector to want to pursue that commercialization of the space industry a little more? Because, I mean, in my opinion, and I'm sure many others that you work with, that could be a dramatic impact on the American economy if it really grew to be bigger than what it is right now. So what are ways that we could encourage more companies to invest in those things, or the ones that already are to invest more?
Yeah, I think one of the biggest things that we're doing is reducing the risk for these companies. So by doing things like Orion and our deep space exploration, we get better, smarter about how to do this in a safe and reliable manner. So I think that's a good role for the U.S. government, is to reduce the risk associated with these really difficult endeavors, and that way a private company can come in with a more definitive business plan where the risks are smaller, where investors can see a true profit potential here. And I think that is an appropriate role for NASA and something that we are definitely pursuing. And if you look back in history, that's a very common transition where the government has pushed the state of the art for like railroads and aviation, and then the private sector comes behind when those activities become a little bit more routine, a little bit less risky, and you can see a profit potential. So I see that as definitely one of the ways. And also reducing regulation, reducing bureaucracy, reducing the overhead associated with doing that. That's another thing that we're working on.
We only have time for one more question. We're taking it in here in the room. It's the corner over there.
Quick question. Which do we see carrying astronauts next for American Space Program? SpaceX, Boeing? Is it going to be Orion? Which is going to be...
Well, currently, like I said, we're targeting commercial crew for 2017. Both companies, we just let some contracts for the final development effort to both SpaceX and Boeing. That's what he's referring to. And they are both targeting 2017 to have their systems ready. So let the race begin. We'll see. We are not going to sacrifice safety for schedule. Obviously, we really, really want these systems to come online soon, but we are going to maintain our safety posture to make sure that our astronauts are safe. I think the first flight of Orion is now scheduled for with people sometime after 2017. But again, we don't see that as a competition. These are two very, very different missions. Whichever one goes first, that's great, and I'll be happy and hopefully down here at Kennedy to see the launch.
Thanks, Phil. Appreciate you coming out today. You know, we do a lot of talking about the spacecraft with Orion and today's launch and the test and the parachutes and the re-entry. But one of the reasons we're really flying Orion is to send humans into deep space exploration. So let's roll our next video. Welcome to the stage, astronaut Rex Walheim. Rex.
Thanks, everybody, and thanks for being here. And it's such a pleasure to be here and to share this with you. It's an exciting time here. And you can feel the excitement in the air. You really can. I haven't felt this excitement at KSC for quite a while. So I'm glad you're here to share in it and also to help tell everybody else about it, too. Now, about 4 years ago, when I was training for STS-135, that was the final space shuttle mission, I often got the question, was it a mistake to retire the space shuttle? And I would reply, well, it depends. If we do what we say we're going to do, and we take the money that we were spending on shuttle operations and take that and buy these new vehicles and build these new vehicles that can go farther than we've ever gone as humans, ever in the history of the Earth, then it's not a mistake. Well, this EFT-1 mission, now 4 years from that time of the last shuttle mission, or 3.5 years, it's a big step toward fulfilling a promise we made to the American people that we were going to take that money and we we're going to build some incredible vehicles that can do amazing things. And you guys are all here to witness it. Now, in the aviation business, we refer to our aircraft by their tail numbers. You guys have probably heard that before. And so in that vein, this makes it EFT-1 Orion tail number 001. And so now, as a 4-hour flight, you know, and with no crew on board, you might think, well, that's not so impressive. But what I think you need to do is you need to take a little bigger picture and look what this amazing vehicle is going to do, not just this one, but the fleet of vehicles, because it really is an Orion fleet. It's not just one Orion and a different Orion and so on. This is a vehicle that can go basically anywhere. It's not destination specific, as you heard everybody else talk about, which is really the flexibility of this vehicle. And so it's really got some incredible capabilities. Now, you've also heard that it's not easy to do this. You know, we have all the technical challenges they've had in the past programs. You know, with the Apollo program, there's all sorts of technical challenges you have to get through. But to be honest, one of our big challenges is that we do this in a very constrained budget environment. That's not necessarily what we'd want, but that's the way things are. And that's okay. We can deal with that. It just takes longer to do these things, and it's also harder. One of the problems is that we can't do everything we want to do. Sometimes with earlier programs, you could try a few different things, and then if they didn't work, you figure out which one works best, and you pick that one. And then, but with this one, with Orion, we pretty much have to do everything right the first time, because we just don't have time to do it over again. So one of the things that some of the folks in the Apollo program would tell me is that they wish they had had a chance to take a step back once in a while and appreciate what they were doing. You know, they were working so hard when sending people to the moon, they didn't step back and say, wow, look at what we're doing. And so I think that's important for us to do. And because we just don't really have the chance to really enjoy the milestones sometimes. So I kind of want to take a look at that amidst the hard work that everybody's doing to see what's ahead. Because now, as amazing and impressive as this first launch as EFT-1, you know, it only gets better from here. And just down the road is Orion tail number 002. Now, you've probably heard of that as Exploration Mission 1. This is the second mission of Orion, and it's going to go farther than any human-rated spacecraft has ever gone on its second flight. So it's going to be a big challenge, and it takes a while to get there, but it's amazing what we're doing with each step. Now then comes Orion tail number 003. Now, Orion tail number 003 has a special place in my heart because 4 of my colleagues from the astronauts are going to be climbing on board that and go on an adventure of a lifetime. So it's going to be absolutely amazing. Now, farther down the road, there's also going to be another Orion on top of the launch pad. Now, I don't know what the tail number of this Orion is, but they're on board on top of the Space Launch System. Will be in the familiar shape of the Orion spacecraft, and on board will be people going to Mars for the very first time. It's an absolutely amazing accomplishment that's going to happen. It's going to be one of those points in history. Do you remember where they were when people went to Mars? And it all traces back to what's happening tomorrow with the launch of EFT-1. This is the first flight of a new vehicle, and the first flight of a vehicle is always a big deal, and that's what is so important about it. Now, it's going to be a long time. It's going to be a long journey. There's no question. There's going to be things that don't always go right, and we're going to learn from them, and we're going to recover and continue on. But it's going to be a fun one. I'm glad to be part of it. It's an amazing team. Everybody has to do their jobs. Everybody from the engineers to the managers to the folks in Washington. We've all got a job to do, and it's a long, hard job. But we're up to it to have a chance to get on that path to send folks to Mars. Now, as you know, when that crew is on the board, that Orion tail number X that's going to Mars, it's going to be an incredibly historic day. But then when that happens, amidst all of the celebration and stuff, I think a few of us will take a look back, all the way back to a December day in Florida when we set off the very first Orion, tail number 001, on its maiden journey. And that's happening tomorrow, and that's why it's so important to me. So that's all I had to say for kind of prepared remarks, but I want to open up for some questions if you guys had any.
Thanks, Rex. We'll take a couple questions here in the room, and then if we have time, we'll go to the field centers.
So obviously, some of the pilots that are going to be on these future Orion missions may not even be born yet.
Yes.
So how are you and NASA planning to start to provide an excitement for the younger generation that's going to be piloting these future generations?
You know, I think that the biggest thing you can do to excite the next generation is to show them. You know, there's a lot of people who talk about they don't know about what the space program is doing, but when you show them, they understand. You know, when I go to schools and I talk to kids, I show them my pictures, and they understand that. But the best way is what's going to happen tomorrow. When you guys see a rocket launch, you know, those of you who've seen it one before, you know what it's like. You don't just see a rocket launch, you experience it. And tomorrow, just take it all in. I mean, feel the vibrations from that rocket. It's absolutely amazing. And when people see that, the general reaction is pride in their country. When I see a rocket launch from here, it's just, I have this incredible sense of pride that I live in a country where we have the capability of rocketing people, just slinging them off the planet all the way into low Earth orbit. And now we're working towards slinging them off into deep space. So if you get them to see the program, to feel it, I think they get excited about it. And the more we do, the more they're going to get excited. So EFT-1's tomorrow. It's going to be really neat to see it on top of a Delta IV Heavy. But like I say, Orion tail number 002, what's unique about that is the ride it's taken to orbit, the Space Launch System. An incredible mighty rocket. And that thing is going to inspire people even before it flies. You look at that VAB out there, and you just imagine the SLS rolling out of there. It is going to take your breath away. And then when it flies, America and the rest of the world, they're going to sit up and take notice, and there's going to be no doubt about the vitality of the American space program. It is going to get people's notice, and it's going to be exciting. So I don't see any problem. The hard part is just moving on and getting piece by piece and getting there. But it's going to get more and more exciting right from here. Yes?
Hi, a question along the same thread.
Sure.
Obviously, being an astronaut is a dream for a lot of people.
Yep.
What advice would you give the kids and the young adults who would like to be in your position one day?
There's a couple of things. First, obviously, is to work hard in school, and people go, well, what should I study? Well, you know, the scientific and technical fields are where the majority of the astronauts come from. So science, medicine, technology, that kind of thing is important. And then getting a hook into the space program too. You know, working at one of the field centers, working with one of the contractors, that type of thing. And then being persistent. It takes a lot of persistence. And you know, the neat part about it is if you try to be an astronaut and you work in the space industry for a while and you don't get to become one, you're still in the space industry. I remember when I was a flight controller once, and so this is a long time ago. Well before I was an astronaut, I was a flight controller. The STS-26 shortly after the Challenger mission, and I came down here as an engineer. I was working as part of NASA, kind of a back room for the control center, so a very small part of it. But I remember coming. I had one trip to the Kennedy Space Center before the STS-26 launch, and I remember standing right out in that field out there and looking out in the distance, and I saw the vehicle. It was Atlantis. It was Discovery. Discovery was on the launch pad, but far in the distance, I just looked at Discovery, and I remember thinking to myself, I can't believe I'm a part of this. I mean, I had a tiny part. I was working landing gear and brakes, but it was so incredible for me to be a part of this. And I feel the same way when I look at Orion. You know, honestly, I'm not going to get a chance to fly on Orion. It's a little bit farther out, and I've already flown 3 times. But I look at that Orion on top of the rocket, and I think, man, I am so proud to be part of this. It's just such a neat feeling.
We have a lot of questions. We'll try to get to them all. We have next one is at Marshall Space Flight Center in Alabama.
Hi, Rex. I'm curious. My name's Mark Simpson, visiting from Chattanooga, Tennessee. I'm curious if you're aware or have been made aware of the quality of life the astronauts will be experiencing in a long-distance voyage like going to Mars. I've heard some talk about a habitat module. Will the extended module just carry fuel, or will it be something that the astronauts will be able to go in and relax in? Seems kind of odd to me to expect 4 astronauts. I mean, I know it's a roomier capsule, but it seems kind of odd to me that 4 guys got to stay in a small area for that extended period of time going to Mars. So I'm wondering, as an astronaut, have they clued you in on some of the more life comfort parts of the journey for a long distance like Mars?
So for the long distance, the habitation module hasn't been designed yet, but you're absolutely right. You can't stay in the Orion capsule for 3 years. I mean, a Mars mission could take 3 years potentially. So you have to have a habitation module that's going to have some of the comforts of home to a certain extent. And it's going to be a tough journey. It is going to, one person likened it to me like, when you go to Mars, you know, it's all exciting and stuff, and you know, I love being in space and flying, but it's going to be different going to Mars. Several days, maybe a couple of weeks outside after your launch, you're going to be coasting to Mars, and you're not going to have the beautiful Earth to look back on. It's going to recede into becoming just another star, and all you're going to have around you is stars. And what some people say, and I agree, is it's going to redefine the meaning of the word loneliness. It's going to be tough, and not everybody can do it, but we have explorers. They're the same people who crossed the oceans way back when. They have the same kind of grit and determination that they can do that kind of thing, go on an extremely long, dangerous voyage like that.
We're going to take one more for the field centers. We're going to Goddard Space Flight Center.
Okay.
Yeah, hi, I'm Mike from calling in from Goddard. Yay. In the early days of the space program, Mercury, Gemini, Apollo, and the shuttle, it was well known that the engineers took a lot of input from astronauts on what the astronauts wanted and were looking for as far as the design of the space capsule. So wondering how much input the astronauts had in Orion.
A lot. And actually, I am the astronaut representative to the Orion program, so I work on Mark Geyer's staff, and I give him our input of what we think is important and what we think we need for this vehicle. And so it's a hard program. Like I say, it's constrained by money, it's constrained by weight, and it's a difficult engineering problem. And so we're cognizant of the fact. So when we talk about what we think we need, we really have to ask ourselves, do we really need this? Is this essential? And if it's not essential, it gets pushed off potentially. So it's not an easy process, but we are a part of it, and it's an interesting process to be a part of. Another question, yes.
First, I got to say, I saw you launch on 135.
I see the hat.
It's really
Very nice.
an honor to be here with you, seeing
Well,
you.
thank you. I'm glad you were there to cheer us on.
Yep. And,
you must have been a lucky charm. It's the first time I launched on time, so I assume tomorrow we're going to launch on time
awesome.
too. Is that
Let's
correct?
hope they carry us over.
Okay, good deal. All right, way to go.
So I just wonder if you can tell us what the current thoughts are for the flight profile of tail number 003.
Yes. Yeah, what's the profile going to be like? That you bet.
Where are we going?
Exactly. So right to the it'll be the lunar vicinity. We've talked about the basic trajectory would be to do a high lunar orbit of that. Now there's still some trade space there. How do you want to do that? Do you want to build up to go into the moon? If you have depending on what capabilities we have, we may be able to stay longer in low Earth orbit. Because the tricky part about tail number 003 is that's the first one with the ECLSS system. So the environmental control and life support system. It's got the stuff that keeps us alive. You don't need that for tail number 1 and 2. 3, it's very important. So you want to put a little bit of time on that before you make that big burn to the moon. So we're gonna see what the best trajectory and the best profile is. But I think we can get the best of both worlds. Get a little bit of time on it, and then take a shot at the moon. So it's pretty amazing, and it's gonna be a game changer. It really is. But there'll be no shortage of astronauts volunteering for that mission. Yeah.
Thank you.
Thanks.
Hi there, Bobby Russell. I'm a pilot and also a suborbital spaceflight trainee at X-Corps.
Oh, great.
And so I haven't heard anybody talk about tomorrow in flight profile. As far as, are there going to be pitching maneuvers? Are we going to actually test the maneuverability of the capsule?
You bet. So they are going to a certain extent. So once it separates from the upper stage, it has to reorient itself to basically have the right profile for reentry, and that's very important. So that is a good test of the reaction control system. Which each one of these is not necessarily a long test, but they're important ways of testing each one of these systems, because it really does get a good cross section of the importance. You get separation systems, you the parachute systems, and so there's and the guidance and navigation and propulsion systems. So there's a lot of different tests in there.
Unfortunately, that's all the time we have left for Rex Walheim. Thank you for joining us.
All right, thank you. Appreciate it.
So a lot of work went into making Orion, and this test flight happen tomorrow. There's all kinds of testing that happened before, and a lot of milestones were reached. Let's check it out. Let's see the new video. And for our grand finale, let me introduce to you the man who can answer any of your questions about Orion, Mark Geyer, the Orion Program Manager.
Thank you. Thank you for coming. Look forward to some questions. I know you guys, I already heard you talking to Rex, and you had some great speakers today with Gerst and Charlie and John. So I'll talk a little bit about Orion. I think I already heard some questions about Orion, so you already know a lot about it. But I'll tell you a little bit from my perspective, and then we can dialogue on things that you're interested in. So Orion, of course, is the capsule system that takes the crew out into deep space. SLS gives us the velocity, but Orion is where the crew resides and does their work. It's how it's broke up into 3 different pieces. The crew module is the main focus, and that's also the main focus of the test tomorrow. Crew module is where the crew lives, sleeps, works. It's where they interact with the vehicle. It's where where their seats are. It's where they have their displays and controls to interact with the computers. It's where they stow their food. It's where their suits would be. And also inside, the crew module itself can act as an airlock. We can depress the cabin, and they can go outside and do EVAs. The crew module also then has the heat shields and the parachutes and all the computers that do all the navigation and guidance, the RCS system that controls how we point Orion so that we enter safely. Behind the crew module is what we call the service module. The service module is where you have the big tanks for the water and the air. It's also where the big prop system is. It's where the radiators are to cool the systems. It's where the solar rays are going to be to generate power when we're in deep space. That service module part is actually going to fly a full service module on our next flight. On this flight, it's basically a structure. It's basically a service module structure, and we're flying it because we're going to test some of the key pyrotechnic separation events, like these fairings you see in the movie come off, and the separation between the crew module and the service module, which is obviously one that's got to work. And the reason we're testing those particular systems on this flight is pyrotechnic devices, they have to work. You know, they have to work when you need them to work. So they got to be high reliable parts because they are fundamentally critical operations. And then on the very top of Orion, when you look at it, you see it on the top of the rocket. You see the pointy part and the dome part. That's what we call the launch abort system. The launch abort system is there that when we fly people, in the very small chance that we have a problem with the rocket, we can get the people safely off the rocket and get them out over the water and land safely in the crew module. And so that's called the launch abort system. It's a very large solid rocket motor. It's about 500,000 pounds. It'll accelerate the crew at about 12.5 Gs, 12.5 times the acceleration of gravity, so it's quite a ride. But the main thing is to get them out, get them safe. And so we tested that system fully up in White Sands a few years ago. On EFT-1, the only part of the LAS we're testing is basically the structure and what we call the jettison motor. It's the motor that basically pulls the cap off the crew module in the nominal flight. If everything's going well and we don't need the abort system, the jettison motor pulls the LAS off. And that part we will test tomorrow. So that's what Orion is. Couple things about what makes Orion different. Orion is built from the beginning to be a beyond low Earth orbit spacecraft. And what do I mean by that? When you go beyond low Earth orbit, there's a lot of things that are different. Number one is the duration. If you're going to space station, it's a day and a half up, maybe 2, and a day back down. So 3 to 4 days max. For our missions, at a minimum, you know, getting to the regions that we're talking about can be as much as 5 to 10 days in one way. So Orion's built to be a 21-day mission for 4 people. So that drives the obvious things like food, water, air, those kind of things are pretty straightforward. The things you need to do to pull the carbon dioxide out of the air for the crew. So we're bigger to handle those kind of things. We have a bigger volume also for the crew. You know, the crew is together for a longer period of time. They need a little more volume. Also, it drives the propulsion system is about double what you would need in a LEO system. Heat shield has to handle entries that are about almost 1.5 times faster coming in. So the heat shield's got to be different than a low Earth orbit spacecraft. And one of the things that people don't think about is emergencies. When you're in low Earth orbit, you can get to the ground in about 45 minutes. So if you had a leak in the cabin, you could crank up the oxygen, get to the ground, you're okay. When you're at the moon, you can be as much, in the missions we're talking about, anywhere from 5 to 10 days from home. So your systems have to be highly reliable so you don't have those problems. And then if you do have them, because you have to protect for the fact that you might, so we protect people like Rex, you got to have systems that can protect the crew. So for an example, if we had a depressed cabin, the whole cabin is depressed. All the systems will work on Orion. They're built to work. and the crew can stay in their suits on the ecosystem for 6 days, and we can get them home. So that's the kind of thing you need on a deep space spacecraft that drives complexity in the systems, reliability, those kind of things. Just an example. Tomorrow is a key test for us. It is, as I mentioned before, the main test is for the crew module. We're pushing on the key crew module systems, entry, navigation, and guidance to make sure we're pointed, the computers are working. We're going to see high radiation, so we're going to make sure the computers can work through that. We'll deploy all the parachutes. It's important that the parachutes all work, so we're going to deploy them in exactly the environment we expect to see on a nominal flight. And then we'll also do these key separation events. I mentioned in the press conference I had earlier today that the unmanned tests are really important, because on those tests you want to push the vehicle very hard, because this is your chance to learn things that you didn't expect. So as I mentioned a couple days ago, I hope, certainly part of me hopes, that everything is perfect and we get the big high five at the end, right, and we go have a party. But I also, what I really want, though, is if there are things that are eluding us, and there are things that are beyond what our models tell us, but are the truth, then I want to learn those tomorrow, so that we can adapt to that and make the best system to take people beyond low Earth orbit and keep people like Rex safe. So that's a key part of tomorrow. So I think that's enough for me talking. I think it's better we get to questions.
Thanks. 2 questions from the room. We're going to go to the centers and come back here to the room over here.
Hi, Anthony Jordan. I'm a freelance photographer and social media consultant out of Miami. I just wanted to say thank you on behalf of everybody in the room for taking your time today and providing this information. It's a plethora of knowledge and a really, really amazing experience for a lot of us here, first-timers, by the way. My question is, what was the creative inspiration behind the design of Orion and the entire system taking the spacecraft into orbit tomorrow?
So the inspiration really is about getting people out into the solar system, right, and exploring beyond low Earth orbit, getting out and seeing things differently. Many of you, I think most of you, when you were born, we'd already done Apollo, probably. So I remember before Apollo, and I remember the first time we saw the Earth from the moon, and it changed our whole perception about this planet. So exploration is about things like that, is that we go out and we go look at these things like these asteroids. We go out and actually visit the asteroids where they are. We actually go to Mars. We're going to learn things like that and things about life itself on Mars, those kind of things. That's the inspiration for why we want to do this kind of a thing. The Orion design in the Orion mission really came out of looking hard at what these missions look like. What are the requirements for the mission? How long do we need to be? How safe does it need to be? What's the crew size we need? What's the right shape to get the lowest mass, safest entry, right? So that's where we get this shape. That's why it looks like Apollo, because the physics haven't changed since the 60s. Coming back on those speeds still work the way they did then. But the insides are totally different. So they're all state-of-the-art computers and other systems. So it makes it a much more capable system than we had in the 60s. Yes, sir. Oh, I'm sorry. You're gonna pick the answer. Sorry. Yeah, I'll look at you.
Hi, thank you again for being here. I'm Emily Calandrelli, host of Exploration Outer Space on Fox. And as you know, public support, specifically U.S. citizen public support, is essential for the sustainability of programs like this. What advice would you give to U.S. citizens on explaining and communicating the importance of these programs to the people that represent us in Congress?
So two things I would say. First was the comments I made about exploration, right, about how it changes how we view the world. I also think about when we go to Mars and we learn about the Martian atmosphere, about what happened on Mars. I think it can tell us a lot about the Earth, right, what some of the risks might be on Earth. So I think it can have tangible benefits for us, as well as just understanding life itself. If we find life on Mars, what does it tell us about life here? So that's huge. But I think the more tactical or more day-to-day stuff, all the money that's spent on Orion is spent on the planet. It's obvious, but it goes to people like there's a shop just down the road here that makes parts of Orion, test parts. It's a little bigger than a mom and pop shop. It's about 30 people. But the kind of jobs that we give them are high-tech jobs, and they're difficult jobs because we have very tight tolerances and specifications for the kind of parts that we need. So it requires them to train their people. It requires them to check the quality. And so what you get then by spending money on things like this is you get a workforce that has higher skills that can be used on any jobs that we have. So I think it helps the United States technology base too. So it's real important.
Next Let's go to Glenn Research Center in Ohio.
Hi, my name is Ryan Reed. I teach engineering at Northview High School in Sylvania, Ohio. I just had a question concerning the advice that you would give students across the nation and how they could possibly get involved in this program this year for tomorrow and then possibly in future years.
I think so a couple things. One is the key thing is to keep focused on math and science. That's your best opportunity for these kind of jobs, right? A lot of engineering jobs are driven by that. NASA, I think, is doing a very good job these days of getting links out and descriptions of the work that we're doing every day. So as teachers, you can go to those links, you can see videos, you can see examples of the work that we're doing to get kids excited about it. NASA has done a really good job also on this flight of having some what I would call outreach events. Like we had a competition. You might have met these kids already. We had a competition to design a radiation sensor for this flight. It was across the country. There was 5 teams chosen. We picked the winner a few months ago, and they're actually flying their experiment. So look for those kind of things. NASA's trying to do more and more of those things to make a connection with the schools and get kids excited.
We'll take a question now from the Jet Propulsion Laboratory.
Hi, my name is Laura Spencer. I'm in education from San Diego. My question is, with all of these satellite locations of NASA social participants, how has the actual satellite location helped contribute to Orion's launch tomorrow? In other words, what did Jet Propulsion Laboratory contribute to Orion's launch in the morning?
Great question. There's one key part that there's a communication network across this country that involves including the satellites in geostationary orbit, the TDRS satellites, but as well as ground coverage areas, and then all the lines and systems that tie all our pieces together. Because we have people here in the ONC that will be like our engineering experts. There's people in a hangar across the way on the Air Force side. There's people at JSC who are going to do contingency commands if necessary. There's people in Denver supporting if there's issues. So you got to tie all those people together to get that telemetry, the data back. So that whole network integration, making sure that it's set up, that all the pieces are there, that we've tested them all, that was a JPL job specifically on this task. JPL was also a key part of the team that decided our heat shield material a few years ago. They're a key part of that. And they've done other work with us on GNC and other areas like that. So they've been a big part of the Orion, difficult tasks that are part of Orion.
I actually have 2 questions, if I may. The first one is with EFT-1. I've been trying to look for information about what's inside Orion for EFT-1 in relation to for astronauts. Like, do we have any crash test dummies to measure the G's with all the different stages of slowing down? And the second question is, what logistical issues do you foresee between the differences of the launch vehicle? For example, tomorrow it's a Delta IV, and its future vehicle, which will be SLS.
Good question. So the inside, if you looked in the inside, you would basically just see the computers, and you would see some slabs of metal, which we call mass simulators. So we have a concentration of metal that simulates the weight of the seats and the crew. And we have the same thing for the display panel, because we don't need to fly a real display panel. They're fairly expensive, and there's nobody in it to push the buttons. But we put the mass up there so that we see how the structure reacts to having the mass hanging off of it like that. So we simulate the vehicle is flying, and it flies as if it had the crew and those other pieces in it. That was a key part, that it flies with the right pieces. As far as measuring velocities, we have accelerometers and other load indicators, so we'll see those parameters. I expect on the next flight on EM1, we'll actually have a seat and some way to measure in the specific locations where the crew is going to be, what we think those responses. But you can get a lot by this flight and how we expect the loads would transfer through a seat, because we can do tests on the ground with a seat and crash test dummies to get that last piece. So it's a great question, because that's really an important part of the landing. It's not just that the computers are back, okay, but how did the crew react? Yeah, it's a big piece.
Hi, my name is Heather Hinkle, and I actually work for one of your sister
federal agencies for the U.S. Geological Survey. And I think the socials that NASA runs are really great because I think it's a great way to get the public involved and also to get the word out. The question I had was, there's a 3D printer up on the ISS right now, and I know that they're starting to look at how it could be used and how the structures are being formed. And I was just wondering if Orion has given any thought to how the 3D printer might be used in the future, or are you just kind of waiting to see how it goes in the ISS?
So we have actually parts on this flight that are made in a similar process. They're fairly simple part. It's a vent on the back shell because as you go through the atmosphere, you want to make sure that the air that's on the other side gets through without causing any damage. So we have vents that are made in a similar process to that. On EM-1, if you look at the side of the Orion and you see the service module fairings, eventually they'll come off. At the very top of those fairings, there's a piece of metal that is called a snubber. It holds the fairing on, and it makes it so the air can go by that transition very easily. But it's a fairly complex part. It has a lot of curvature in it, and you need a little bulb lip at the end of it. It's very hard to make on a machine. So it turns out on EM-1, we're also already, for the next flight, we're already making them in a 3D printed-like process because you can make a very complex part very simply. So we look at where it makes sense for us. And I think it's a great advancement, and I expect it will continue to be that way, and we'll adapt to that.
Thanks. Our next question is from the Johnson Space Center.
Hey, Mark. Tim Cooper from here in Houston, longtime listener, first-time caller. Thanks for having me. My question is back to EFT-1, the trajectory. First time we've been this deep into space for decades. Is there any special considerations to the flight path to avoid all the stuff that we've put into orbit since then?
That is another really good question. We did not try to avoid pieces of the orbit. You know, we really focused on what the orbit was that we needed in order to get the objectives for this flight. And as you remember, the main objective, one of the key objectives, which is really driving the altitude, is the heat shield. So we're trying to get very close to lunar entry velocity, so we go to 3,600 miles up. We do fly through regions in lower orbit that actually do have a significant amount of orbital debris. It's still not, by itself, not a huge driver to the risk of the flight, but we do calculate that. NASA has a model, a very detailed model, that we use data from radars and other things that we can kind of tell what these clouds look like, the speeds and so forth, the kind of materials. And we have a model that helps us project that. Orion is designed to protect itself against a lot of that. If you look at the back shell of Orion, those are actually shuttle-like tiles, and they actually are pretty good for a pretty good damage tolerance for getting hit on from some orbital debris. The heat shield itself, the bottom is not so much, and you might notice that it's pretty much protected by the service module CMA, so that's part of why that's it. We try to keep that protected. So that is one of the things we consider and as far as the overall design of Orion, because it will fly through these regions. But on this particular flight, we did not change the path, but we did do an assessment so we understood what we thought the risks were.
Let's take our next question from Stennis Space Center.
Hi, my name is Andrea Pearson-Haas. I'm a student at the University of Texas at Dallas, and I am reporting to you from Stennis Space Center. My question is, we see Robonaut on the International Space Station. Do we have any measures to have a cognitive robot of some sort on this long space mission to assist with the physiological conditions and reduce human error?
So for the first few missions like EM2 and 3 and this asteroid redirect mission that we're talking about today, we would not. You know, those are relatively short missions. 21 days, I think, is the longest period. So that on those particular missions, we wouldn't. You know, one of the reasons Robonaut makes a lot of sense eventually for space station is there's a lot of operations that are somewhat repetitive, and I know they spend a lot of time working on actually being able to move the robotic arm from the ground that saves crew time on board. So that's one of the reasons why you like to go to robotic operations, to save that precious crew time that you have on the astronaut. So in our particular missions today, the 21-day missions, it wouldn't be a big driver. When you're going on to Mars, I think that's certainly something that you would start talking about. How can we automate more of the work? to reduce the overhead and the work that the crew has to do. I think fundamentally, though, the whole idea of sending humans to Mars is because you want the human on Mars, because humans adapt very quickly. They can think quickly. They can adapt to scientific things they find very quickly, like the guys, like the scientists we sent to the surface of the moon. It was a huge advantage to actually have humans there and update and change their experiments based on what they found real time. So.
Hi, my name is Sri Srinivasan. I'm the Chief Digital Officer at the Metropolitan Museum of Art, and it's an absolute honor to be here. And I want to thank everybody at NASA for bringing us all here. So thank you very much. We really appreciate it. Good luck tomorrow.
Thank you.
A quick question about the role of animals in space research. A generation ago, or many generations ago, I guess 40, 50 years ago, there would have been an animal of some kind on a mission like this. What point did NASA see the light and the value of not doing that? And do you ever see a time when not just humans, but animals would also fly, not as experiments, but because that would be a good thing for humans to have animal companionship on these long trips or once they're there?
Well, I think, yeah, great question about companionship, because those long missions, you know, even though my dog drives me crazy, I think I wouldn't want him in Orion with me for 300, you know, for 3 years, but still he's a great dog. It's a great question. I don't know. I think that is, as far as one of the key things about going to Mars that could be a very long mission is the psychological effects and what are the things you can do. Certainly taking other people is a key part of that, but I think what you're saying makes a lot of sense, maybe animals as pets in a sense. As far as experimentation, you know, remember the 60s were a different time. We had never sent anyone in space. We really didn't, you know, we had instruments, but we'd never seen really what was going to happen physiologically, what would happen. So it was a different time, and I think we know a lot now, especially since we have humans on space station full time. We know a lot about what happens to the human body. And so I don't think we need to do those kind of things today. So.
Hi, my name is Katie Searcy, and I'm representing the students at Mountain Park Elementary School in Roswell, Georgia. And Luke from the 4th grade has a question. What in the world will the astronauts do for that really long trip to Mars? What will they be doing?
Great question. I don't think my son could go about 10 minutes without his phone or his Reddit account, you know, so I expect that's another great question about what you can do. Certainly there's going to be things we can do as far as training for the mission itself, you know, keeping your skills. Let's say if you're going to be the pilot that's got to land the mission when you get there, there's training runs you can do so we can make sure they run through that. There's maintenance. There's going to need to be maintenance on the spacecraft that you're flying because you're never going to be able to put in all the redundancy that it's going to fix itself all the time. You're going to need to take things apart. Much like space station, right? A lot of space station today, the crew does a lot of the maintenance there today, so they're going to have to do some of that. But I think that's one of the big questions is when you've got a year-long mission, I don't think it's certainly not long enough to talk about this hibernation stuff, but what else would you do? What are the other things to keep the crew occupied and keep them sharp? So it's a great question, and so maybe he can help us as we research those things.
One more question. It's right
okay.
here.
Hi, I'm Carrie Kukral from Raw Science TV, and I'm wondering, we've often heard about how much computing and electronics were accelerated by the Apollo program. What predictions might you make about Orion in this Mars journey that will be accelerated?
Well, you know what I really like about engineering. I'm an engineer. What I really like about engineering is you have to take the theory about what somebody says might work, and you actually have to put it into something that actually has to fly, and you have to face those challenges to make it work. So I'll give you an example. The network on Orion, as you know, the network is how the computers talk to each other. We have a state-of-the-art network that was actually an idea about how to get a very fast but very reliable Ethernet capability, and it was called a time-triggered gigabit Ethernet, and it was a concept that people had started thinking about. But we actually made it. We actually built it, and now we've actually run it, and it's actually a capability now that airlines and others can use because it's been developed through this team. You know, so other people had a great idea they were using for other implementations, but we needed it, and we drove it to an implementation. So those are the kind of things. What will happen to Mars? It'll be something well beyond that, I'm sure. I think the key for a system like Orion is it needs to be able to adapt, because a lot of things are going to happen. And we need to adapt because there's a whole bunch of technology in the computer world that happens outside of NASA, and it's driven more by these communications things that everybody is using, and we need to take advantage of those and build off of those. We do have special environments, like the radiation is a big deal, so these really fast computers are actually very susceptible to radiation, and they have to be highly reliable. So I think the key for us is to take those new ideas and put them into space application, and then make sure that we open source it so people can use it as an advantage. So great question, because we got to be able to adapt.
Ladies and gentlemen, Mark Iyer.
Okay, thank you. Thanks.
Thank you, Mark. Thanks, Mark. That concludes our NASA Social. Hopefully everyone learned something, a little bit about our Commercial Crew Program, NASA's Journey to Mars, and Orion's first flight test. Just a couple quick programming notes. I'm sure everyone watching and here in the room will be up for our television broadcast, which starts at 4:30 a.m. Eastern Time, live on NASA television. You could tune in at www.nasa.gov/NASA-TV. TV. Also, remember to use the hashtag Orion in all your posts. And thank you for joining us. Go Orion. We have a short video we're going to play for you to conclude the program.